Hi again, and this time we're going to talk about signaling 102. Hi, Fippo. What we did last time was review how the signaling server works, and OGS parts of it, and the messages. And what we've particularly seen is that when you send these messages, the server doesn't really care what goes in them. And this is going to change when we go and do the walkthrough in this lesson. So this time we're going to go and deep dive into the index.html file and focus on the JavaScript parts of it. Pippo, can you share the code?
Yes. So we're going to focus on the connection function this time, which is what happens after get user media. And basically it connects to the signaling server.
So once we called get user media, we allowed access to the camera and microphone. We have this local stream variable, and we call the connect function, which does everything in a way.
Yes. And then maybe depending on the URL, we will call the call function.
Okay.
To connect the peer. So let's look at the connect function. It does return a promise because that way we know easily when the connection is established. And this part is basically just waiting for the WebSocket to open, and then it resolves the promise.
Okay, and the WebSocket goes to the exact same location where we have the web server today, which will be localhost port 8080.
Yes, it is going to go where the file was fetched from. And we didn't hardcode that, but did this fancy connecting to the same protocol and the location where we got the file from.
Okay.
In production, you would set your signaling server WebSocket URL here. So once we have this WebSocket, we add a couple of listeners open to know when we are done establishing the connection. An error handler, because we always want to see errors. We also have a handler for closing, which would happen if we stop the signaling server. And it's a bit undecided what you do there. You could interrupt your WebRTC connections, or they could just continue to work.
And here we decided to let them continue to work because it's peer-to-peer, but then we lose track of where they are and why.
Yes.
Okay.
And the important thing is the handling of the message.
Now, what I've noticed before going to the message one is that when we open the connection, the client doesn't send anything. It's like we connect to the server, and in our case, the decision was not to send any type of a message, but let the server do whatever it wants with us.
Yes. And we've seen that in the signaling protocol slides, we said we're going to connect to the server, and the server is going to send us a hello message with our client ID back.
Okay, and that's what we see here is the first message in the switch. Like after we get the listener for message, there's this parsing of the JSON, which is great, and then we switch on the type of the message. And the first one is this hello message, which will be the first thing that we expect to get back from the server anyway.
Yes, and it's basically guaranteed to be the first message to come. And we would need to be careful to only accept it from the signaling server in production, not for the simple sample.
Okay.
So we store the IDs that the server gave us. We display it in the user interface. And we set the window location hash to our client ID, which means we can copy the URL we have into a new tab and then just connect there, and it will then connect to our session.
Okay.
And the other method we have here is by, which ends a session from a specific peer. So
this is the hang up button in a way coming from the remote side.
Yes.
Okay.
If you click the hang up button, that makes the client send a bye message to the other client. And the other client, when receiving a bye, it checks if it has a connection from that peer and then closes it.
Okay. So it closes the peer connection, but not the WebSocket.
Right. Because
Okay.
the WebSocket can still be used to talk to other people.
Now, again, one minor thing, you go to peers has and peers get as if we have multiple peers here.
Yes, because you need some way of dealing with the situation where you are in a call, but another offer is coming in. And we're actually going to look at that next.
Okay.
So the next thing is the offer. And it has this handling. If there is no peer for that ID, we're going to accept the call. And if we look at the other part, that didn't. Okay, so if we don't have a peer for that data, we have an incoming call. Otherwise, we have a subsequent offer, like something like adding video to an audio-only connection. So we know we have an incoming call, and we check if the peers map size is bigger than 1. In that case, we're already in a call and we're going to reject it because we don't want to implement a full mesh solution here.
Okay.
And in our protocol, that means sending a bye to the other peer.
Okay, so we tried to offer us something and we threw him away by a bye.
So we create a peer connection. We're going to look at create peer connection in a bit. And then we add all the streams, all the tracks from the local stream to it. And then we call set remote description.
Okay, and the local stream is what we had from get user media.
Yes.
And then we simply add them here as tracks to our peer connection. After we add the tracks, we go and call set remote description. Okay. And now that we have that, we are going to create the answer message.
Yes. So we don't do anything fancy like calling set remote description, then only then call get user media, and then call create answer, because that's a bit more complicated. And we wanted to keep things simple.
Okay, but in, let's say, real life, not when I join a session, but when someone calls me, I would not call get user media before the offer comes in, or before I get some kind of an indication of someone trying to call me. I would first get the indication, then get the user to answer, and then I'll do the get user media and fall through all of these pieces anyway.
It depends. I mean, if you have a very video conferencing style application where your camera is expected to be always on, you would call get user media once at the start of the session. If you have an application like a messenger where the camera isn't supposed to be on, you have incoming calls, that changes a bit. Because there you would call set remote description, maybe send an answer because a user might take time to accept the call. And if you don't send the answer within a certain time window, the caller might think you haven't received anything from them.
Okay.
So in that case, you would call get user media later and then renegotiate it in the other direction.
Okay. Okay. And as usual, we took the simpler approach here.
Yes. Yes.
Okay.
And I mean, in general, we see a lot of this auto accept with all get user media stuff in WebRTC.
Yes, that's true.
Yeah. And we just create an answer called set local description and send the answer back.
Okay. Now, one more question. If I were to write a real application, just observation from my end, I wouldn't use the WebSocket send, then JSON stringify and all that. I would place that in a kind of a JavaScript function, because I would like to wrap the whole sending part with logic so I can replace or change it whenever.
Yes. I mean, this is a very simple signaling protocol. And typically you would have a connection class which wraps the WebSocket, and then you would call a send method on that connection class, which would take care of the JSON stringify on its own. Or it could even do things like send things over an XMPP connection, transform the SDP to XML and stuff like that. But that's more complicated than what we want to show here.
Okay. Okay. And then you deal with the actual CSS or HTML and you disable the hang-up button.
Yes. No, it's enabled.
Sorry, you enable it.
Disabled is false.
Yes, that's true. Double negative.
Yeah. Okay, let's look at the handling of the answer next. It is quite simple. So if we receive an answer, which we send up here, if we have a peer for that ID of the sender, we get the connection and call set remote description on it.
Okay, so now what we did was this. We got an answer message, which means that the other side connected with us. We set the remote description on that peer connection, and essentially we're done. We're starting to negotiate the ICE candidate at this point.
Yes.
Okay.
And the ICE candidates are just as simple. If we get a candidate, we add it to the peer connection, and we're done.
Okay, I remember that in some cases there are race conditions between the candidates and the peers or whatever, or answer versus candidates.
Yes, so if we look at how we send the answer here, there's a very small chance that between set local description returning and our signaling of the answer that there are candidates emitted, because they can start being emitted after set local description. But that happens very rarely.
Okay.
So, and our default handling for any unknown messages is to just log them to the console and make it the developer's problem.
Okay.
So one thing we didn't look at yet was the call function, which is what gets triggered if you are pasting a full URL, including a hash. In that case, we want to call the other peer. And let's look at that.
So what we've seen up until now, in a way, is the message handler of all the incoming messages, but we just connected to a server and waited for someone to send us something.
Yes.
There was nothing that we did intentionally to start a call, and this is how we start a call.
This is how we start a call, exactly.
Okay.
And first we do some error handling. If you already are in a call with that person, why are you calling the call function again?
Okay.
And we create a peer connection. We're going to look at that next. And then again, add all the local tracks to the stream. We create an offer, call set local description, and send it the offer over the WebSocket. And again, we disable or enable the hang up button and say we're in a call with that peer.
Okay.
So next, look at the create peer connection function. It is pretty simple. It's just a helper function to create a connection. We're not really configuring the peer connection. So in particular, we don't have any ICE servers here currently. In a production application, you need ICE servers, and you need a way to get them, because you need credentials for turn servers, and you need to get those credentials from somewhere.
Okay, and we've got a lesson on that.
Yes. Okay. So we create the peer connection. We are listening to the ICE candidate event, and we just pass everything and send it in a candidate message.
This is going to be the following. I receive an ICE candidate from my stun and turn servers. I take that candidate and I need to send it over the network. So what we do is we go to this will go into the message handling function in the other peer as a new candidate that he needs to do add candidate to his peer connection.
Yes.
Okay.
And the other important thing here is the track event listener, which happens when you get a new track from the remote end.
Okay.
And the important thing to understand about the track event listener is that it happens after set remote description, but in that state, the connection is not established yet, and it might still fail.
Mm-hmm.
And if you have an ICE failure and you would just display the video, you would get a black frame.
Okay.
So you always need to listen for the ICE connection and connection state change, which is what we do next. But let's look at this function first. So we are creating we are getting the remote video element. A real world application might create a new video element for that, but we only have a single remote video to make things easy. And we listen to the onloaded metadata event. That event is generated by the browser when it actually renders a frame. And it can only render a frame when the connection is up and running.
Okay. And why do we even wait and listen for it in our application?
Mostly to demonstrate this onloaded metadata, because it is very useful for both the application as well as testing in general.
Mm-hmm. What can I do with it, or what should I do with it in an application?
Because you want to move the state, like you could only show the video when it is actually showing something that can be rendered.
Mm-hmm. Okay.
Also, at this point, you know the size, so you might want to check the video elements, video width and video height attributes.
Okay, and see how they fit into my screen.
Yes.
Okay.
And then we set the remote video source object to the first remote stream. In theory, you can have a track associated with multiple streams, but that's not something that is very well, or that is very useful in real world applications. It's more a thing the API can do and the SDP can do, but why would you do that?
Okay, and probably browsers don't implement it that well anyway.
They actually implement it. There are even tests for it, but what is the use case?
Dual video, I don't know. Synchronized to the same lip sync, whatever.
It doesn't work. Lip sync doesn't work that way. So
okay. Now, let's say that this is a voice-only call. What do I need to change in the things here? It's like I'll still probably need to connect the track to probably an audio element or an audio tag instead of a video one on the screen, right?
Yes.
Okay.
I mean, it depends on what your remote video element is. It can be either an audio element or a video element, or you might, for example, in a more complex application, and there are some bugs that require you to do that, split the stream and display it both in an audio and a video element.
Okay.
Which can be useful sometimes.
Okay. So now we did the add listener for the tracks.
And now we're going to add a listener for the ICE connection state change, which is one of my favorite state changes. And we're just logging the ICE connection state at that point.
Then again, why should we?
Because we could determine that the connection failed. So if the connection doesn't manage to establish, it should go to a state of failed. Unfortunately, in Chrome's Unified Plan implementation, it doesn't. It only goes from a new state to the disconnected state. Okay. Which is a bug in Chrome.
Okay.
We have the connection state change event, which is a newer variant of the ICE connection state change, and it includes a DTLS state change, or the DTLS handshake. So the difference is that ICE connection state change only tells you that ICE worked, but you could still have a DTLS failure after that, and connection state change will allow you to react to that.
Okay, and here I see that again, if we're connected, we enable the hang up button.
Yes.
Okay.
And connection state change isn't implemented in Firefox, but that is one of the small details adapter.js polyfills
Take care of.
in a bit hacky way, but you don't have to worry as an application about these small differences.
Okay.
And for the sake of completeness, we are adding a signaling state change handler, which simply logs the signaling state.
Okay.
Oh, there's a bug here. It should be logging this.
Okay.
And then we add the peer connection to the peers mapping and return it.
Okay. So again, to briefly go over that, we've created a peer connection here. We've set up the configuration with no stun or return servers at the moment. Then we've added all the tracks to it and built all the listeners that we need in order to process the events that are going to arrive. We have three types of listeners. One is the ICE candidates, which are used to get things connected. The track listener, which is about, well, you've got a new track that you need to show coming from the remote. And then we've got all of the state changes listeners.
Yes, exactly.
Okay, great. So let's go to the end of the file again, because I think that, so again, we open the page. The first thing that we do after we open the page and loading the adapter.js would be to understand if there is a hash inside the URL. We call get user media to get our own local video and to show it on the stream, on the screen. We connect to the server for signaling and way to get our own unique user ID. And at the same time, if we have a hash in the URL, we are going to call after we get connected to the server.
Yes, but we wait for that until we have connected, because we don't buffer anything in the current implementation of the signaling protocol. And we also make sure that we have get user media before we connect to the signaling server. So we don't have to worry about the case where we're connected to the signaling server, we receive an incoming call, but we don't have get user media yet.
Okay. And now things that I could change here would be like, well, let's put a call button instead of doing that automatically. I could change the way we get allocated with a UID by username, password, or other authorization mechanisms there. I could change the fact that I have a user feedback to actually answer a call and not auto answer. And all of these things will need to be built into these parts of how we do signaling.
Yes, exactly.
Okay. So I guess we've went through the signaling 102 lesson, and we'll see you in the next one.